So, just one lesson left here in this unit. Today we get into, what about if we're dealing with real information? What if we're dealing with actual experimental data? So what we've been talking about so far in this unit is all given an equation, we're on this line, or given this line, find the equation. That's great. 1.6. The next page after yesterday. Page 56, huh?
57.
Oh, 57. Sorry, please forgive me. Then why are you sitting at the back? Yeah, it's true.
I'll be back. I'll be back. I don't want.
Move back to the work if you want to. This is a class to pass, not to just hang out with your friends. That's brilliant. Move back there. Okay, so here's the difference today. What we've been mostly talking about up till now, page 57. What we've been working on up till now has been, you're given a line, you're given an equation, and you have to work with it from there. Today, instead, what we're dealing with is, what if you're given a bunch of data points? What can you find from that? So this is instead, you're not told, y equals mx plus b. Instead, you're told, all these things actually happen. Is there a relationship? Right? So in a case like this, fertilizer company is looking at the quality of the fertilizer by collecting basically how well different tomatoes will, right? They have a bunch of plants of tomatoes, and they're checking based on how much fertilizer went on these different fields, how many tomatoes grew. So these are all a bunch of data points. You see that in this case where there was 85 fertilizer, there was a yield of 5. That's this point. Where there was 15, there was a yield of 11. Where there was 20, there was a yield of 14. You can see how all of these points are with some data points on the table. So the x-axis was how much fertilizer went on, and the y-axis was the yield. By the way, there probably should have been a title on this graph. Okay, that's one of our rules of graphs. So what would you have titled this graph, given what we have here? How would you title this?
Fertilizer company.
Well, it's a fertilizer company, but what's the graph actually telling us? What's the fertilizer company trying to figure out? Maybe something about like tomato yield with fertilizer usage or something like that? How big tomatoes are from fertilizer or something like that? Well, when you're trying to title a graph, usually what you're actually trying to do is sort of connect how does this part relate with this part? Basically, how does your responding variable connect to your manipulative variable? And I'm talking to you guys. For people who have not been here all that much, it's probably important.
I'm wondering,
What's that?
why is the final kill wrong?
Really good question. Cole's jumping ahead. He's noticing, wait, there's this one really weird one. We'll talk about this. Do you think the issue in this one was actually the amount of fertilizer? Right, this is experimental data. Here's the thing. In experimental data, sometimes things don't exactly match, right? When we drew that line before, it included all of these points. With a scatter plot, we are not going to have every single point exactly on the line. So when looking at this on the whole, do you think the fertilizer affects the tomato yield? Would you say is there a relationship between how much fertilizer goes and what the yield is? Yeah, it looks like it goes up, right? It looks like it impacts it. Yeah, I think so. But could there be other things? Is fertilizer the only thing impacting it? Any of you guys ever watched Top Gear? Old show about cars? Probably a little bit before you. Anyways, then never mind. This next part I want to talk about. I used to work for a farm. This is, I guess, a different thing. I worked for a farm when I was in university. I just basically worked for him during seeding time and during harvest time. I do a little bit of spraying. And I learned farming's hard. There's a lot of stuff that goes into it. Now I just do small-scale farming. It's called a garden. And in my garden, I'll tell you, I've learned sometimes you just try to do everything and the thing just doesn't grow. Your soil might be bad. Maybe there's not enough light. Maybe you just did something wrong. Maybe your 2-year-old son steps on plants a lot. That might be what happens in my house. But there are a lot of things that influence the yield. Some of the biggest things are sunlight, water, the things that help with growing. Sure. exactly. Maybe this one just happened to be the one that got pulled up by wind or something. Maybe this one got cut, or maybe this one had my son Ian's step on it. Who knows? So what's going on with this data point at 85? Something happened. And you can try to guess. You can say, I think it was that whatever happened, but we don't really know, right? We just know it didn't work. For some reason, that one had this much fertilizer. We'd probably expect that one to be somewhere up here. It's somewhere up here probably, maybe more like 30 kilograms that we'd expect from that one, but it didn't. It didn't work. So what's the general trend? What would you say is the trend of this data? And this is the big idea with Scatterplots. What generally happens here?
More fertilizer used, the more yield.
Great. That's it true. If you increase fertilizer, you increase yield. Fertilizer goes up, I just drew arrows. Up the fertilizer, up the yield.
Why do you like that?
Pardon?
Why do you write like that?
Well, my writing isn't great in the first place, but I actually found my writing is slightly messier on here. Sometimes these get a little bit ugly. Should I try it again? Let's see if I can. See if I can make this happen here. Let's try this. Okay, we're redoing it. We're redoing it. We'll zoom a little bit.
That's better.
Yeah, but the issue is when I zoom in further, then you can only see a little bit. All right, I'll try. Now you can read it. So as you increase the fertilizer, you increase the yield. Do you think this would end at a certain spot? Like right now, all we've seen is as you increase fertilizer, you increase yield. I would suspect at some point that stops being true, though, right? If fertilizer is basically nitrogen, phosphorus, and potassium, you probably end up with some troubles if you put too much on. You burn crops up for that. But so far we haven't seen that. I'd like to see the experimental data where it starts going down, because it actually looks pretty linear too. I would sort of suspect that over time the curve would start slowing down. Right? Probably at a certain spot, the gains make it so it's not as worth it. But here we have a pretty decent relationship. If I was trying to make a line here, I have a line tool, so you guys can kind of boss me around and tell me what to do here. But I'm going to start with a line something like this. Does that look about like what the trend would be?
No.
What would I do?
Make the box.
No, but good point. So that's the difference between a scatter plot. A scatter plot is a line of best fit. It's like approximately where it's fit. It's not an exact, because you're right. If it was an exact connecting the dots, it would look like this, right? But that's not what we're doing here. It's not what we're doing. It's not a line graph. It's a scatter plot. So we're just doing a line that kind of matches more or less what's happening here. In general, the rule is actually make sure that just as many are below as are above, and make sure it tries to kind of match what way the data is going. Okay? So that's what we would call like a trend line or a line of best fit. We'll talk a little bit more about how it goes. Oh, and we already said this. What would you expect the yield to be? Is it 30? Does that look like about? Now, to go beyond this, get a little bit more technical. Scatterplots come from experimental data, so it won't exactly follow your line. And there's a couple things we're looking for. One, what's the shape? Does it look linear or not? Right? You could have a scatter plot. You could have a scatter plot in which your data looks like that. Right? You could have a scatter plot where those are your points. Pretty hard to make a line of estimate from that, right? Although actually, if you put it in like Microsoft Excel or Google Sheets with all this data, it still would find your trend line if you want. It would tell you, it would put it so that exactly half or above, half or below, and it would make the best line it could. But that's probably not super linear. Or you could have points that look something like this. I think one like that's not linear. Right? It looks like it's probably actually exponential. It looks like it's a curve, not just a straight line. So that's that first part. Is it linear or not? Sometimes it will be, sometimes it won't be. Direction, positive or not, negative. Is it going up or is it going down? And then another thing we could talk about is, does the trend seem to be strong? Is it really obviously correlated up, or is it a weak correlation? Maybe it's barely noticeable. Maybe they're really tight. Maybe they're not. On this last one, there's also a point that we would call an outlier. This point here is a great example of an outlier. Some point that doesn't fit the data, doesn't seem to fit the trend very well. That's an outlier. It doesn't mean we disregard them, but it just means we say probably something's happening. Probably something is happening that doesn't fit, especially if there's just one like that. And the line of best fit can be used to predict, to show the trend and make predictions. So let's look at this first one. All right, first one, scatterplot. Linear? Not linear. No, it's linear. Looks like it's probably linear, something like that. Direction is negative. And if we also were talking about the strength of the correlation, we would say this is not as strong as this one, right? You can see this one, the points are a lot more tightly bunched. This is a stronger correlation, or it seems to be. This next one, this is not linear. You can see, if you were kind of trying to graph what was happening here, it looks like it goes something like that. That's not a line. Not linear. But it's certainly a positive. Not linear, but it's certainly positive. It's definitely going up. It's just going up exponentially, not linear. Right? If this trend holds, you can expect that it's going to, rise even faster and faster as we continue on this way. This could be describing something like, how many rabbits live on the, in the area of Highland or something like that, right? If they were unchecked, rabbit population growth is exponential. There's 2, and then, there's 4, and then there's 8, and then, they really go up quickly. So when you see something like this, it's not linear, it's exponential. It's growing at a rate that very quickly goes up. Yeah, how about this one? How about C? Yeah, I think it's linear. Looks like that would basically describe it. So it's linear. It's positive. But I notice this is an outlier. So when you have data like this and you see an outlier, just, point it out. This next one looks to me like it's linear, hey? It's linear. And it looks like it's positive. Now, what do you guys think, for example, 2? Which one has a stronger correlation strength here? In between A, B, C, and D, which one seems to be the most strongly correlated? Yeah, I think so too. Now, why do we think D? What makes us think that's the most correlated? Closer to the line, most closely bunched. Nice. So maybe D is the strongest, and then A or C? A or C is probably the weakest. You're gonna say A?
Yeah.
All right. Yeah, I think you're right. The only thing is, because there's this one outlier on C, it would slightly skew it. Okay, how about example 3? Let's take a look here. We draw a line of best fit. Let's determine the equation of our line. First of all, what do we see here? Is this going to be a positive or negative correlation? Yeah, it definitely looks like it. I don't know what the data is. Something per something. But I see that it's negative. Now, I'm actually going to try to be a little bit precise when I'm drawing a best fit by hand. Now, I'm going to show you guys a little bit later in this course how some of this can happen on the computer. Like if we were using a Chromebook, maybe I'll even let you guys try on Monday with some of these. It'll do it for you. If you take data like this, and you put in find the line of best fit, the program will do that for you. And the way that it does it is basically, it first of all is calculating like the trend based on all of these, and it's trying to make it so that it's like splitting the middle. So like if I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 points, it's going to make it so there's about 8 on top, about 8 on bottom. Sometimes it won't be exactly that if some of them are really heavily skewed down enough. But it's more or less trying to split them in half. 2, 4, 6. Oh, I'm wrong. There's 14. So I think it's going to be something like that. Maybe something like that. So let's say it's hitting this point here, 0, 55. And it's hitting this point here, 200, 0. Given 2 points, can I find the equation on the line? Yep. I have B already. B equals 55. I have my slope. Well, I don't exactly have it yet, but I will. My slope is 0 minus 55 over 200 minus 0. If only I could just fudge that and call it 58. That'd be nicer. Negative 55. 200. 11 over 40. Yeah. Okay. So my equation is y equals 0.275 x plus 5. Now, here's the problem. So far, the only tools I've given you for trend line are very approximate. Very approximate, right? Try to find something that fits both of them, like the same amount of top and bottom, and draw a line that follows the trajectory. That's all I've given you. So I'll tell you at this point, my expectation for your line of best fit is that your line of best fit should be something really close to this. Right? Yours may have actually had a y-intercept of 52 or 58 or 60 or somewhere in there, right? Your line of best fit slope may have been like, oh, sorry, there's actually a mistake here. Minus. Your line of best fit may have had a slope of negative 0.3 or negative 0.25. Right? It might not have been exactly what mine is. But this trend line, given the tools we're currently doing, is going to be about this. So in fact, it might even be best to say, in this case, my trend line is that y is approximately equal to this. Right? Because we're doing this just based on what it looks like to me. Now, a tool that's helpful for determining line of best fit, very helpful. So you can grab one if you want, one for Roy. But yeah, that's the gist of it. Let's try this one. Let's try to make a line of best fit here. Something like that is what mine looks like.
No, it's a straight line.
Oh. I know, I'm so talented at drawing lines, aren't I? Don't you wish that you had as steady of a hand as I do?
I wish.
Sure.
Okay, so now that I've drawn my line, I'm looking for some points. I see I have this point here. This point is the point 120, 65. And the other point, this point here is the point 20, 0. There's a bit of a pain here. I don't have my y-intercept, eh? I don't have my b. No, that's my x-intercept. Right, my y-intercept is somewhere down here. So I'm going to have to find that using math. Oh, I hate math. So first we'll try doing our slope. Our slope is 65 minus 0 over 120 minus 20. Or we end up with 65 over 100. Okay, so now let's think about this. If I have an equation where y equals m, 0.65x plus b, and I have 2 points here, would it be possible to use one of these points and find what b is? Just sub it. So I'm going to sub this one in because it seems easier. So I end up with y, 0, equals 0.65 times x, which was 20 in this point, plus b. So 0 equals 13 plus b. B is negative 13. So that's suggesting that this point here is the point 0, negative 13. Or, put a little bit more useful here, y equals 0.65, our m, times x, plus our b, or minus 3. Is it possible that the number that you got is slightly different than me? No, it's unlikely because you're all just copying me. But it is possible that if you had done this yourself, your number might be slightly different, right? It's possible that you may have been slightly up or down from where I was. But because I know the temptation when you have a teacher that's working and it's super excited and moving really quickly, there's a temptation of I just want to do exactly what he did because he's so amazing and I love him. Okay, that's probably not what you're thinking. Why don't you take a moment and try to see. Let's see if you can make a line of Vesta here that bisects the data, goes half on the bottom, half on the top, follows the trend.
I need a ruler, yeah, that's fine. Right, I don't have steady hands like I'm not nervous.
What can I say? I've got skills.
Okay, Mom, that's the rate I think. Hey, come here knuckles.
We just get you. Drink a whole bottle of pomegranate juice and I don't feel bad. That sounds like I looked at I looked at what I do. Let's say this point.
Yo, what are you doing?
Yo,
Look at me. Point. You're not doing
My line back up for a minute. Is this fair? Told you what his skill Maybe no hands. Good try. You guys sure? You guys sure? Oh, you're not just waving at me? You're good. Yeah. Hey guys, I want to just point something out. This is someone asked me had drawn a really good one and I had a question about it, and I wanted to show you how I kind of checked on this. See if I can find my pen. So, let me show you what one line looks like. And this was a pretty well done line. It was just slightly off. So their line looked something like, it was something like that. And so when I looked at it, I said, well, that looks like it's following the trend quite well. But then I just checked, okay, I see there's like 1, 2, 3, 4, 5, 6, kind of 7 under. Here there's like 1, 2, 3, 4, 5, 6, 7, 8 over.
Oh god.
And it looks like it's just a little closer to the under ones than the over ones. So this is going to be really close. And I told you right now, it's okay if we're not exactly hitting what the only possible trend line is. But what this tells me is I should probably shift this just a tiny bit up, right? I should shift it up so that it doesn't have more under than over, right? I want my trend line to be getting so there's the same amount under and over, and that it has more or less the same distance between them, right? See how now it's still basically the same spot, but it's just shifted slightly. Now the distance is a little closer between them, and there's the same amount, right? These are both sort of touching it now, so now there's 7 touching both sides. This is a slightly better trend line here, right? Our goal is to try to be the computer and actually make it so that, our exact difference from the points under is the same as the distance from the points over. We'll never get exactly there, but something like that. Cool. Okay, so in this case, I'm looking for 2 points. I'm going to say I have a point right here. Right here I have a point. That point is the point 120 and 40. Right here I have a point. That point is 50 and 25. So my slope, m equals 40 minus 25 over 120 minus 50, or 15 over 70. Great. I've been writing them all as decimals. You don't have to, right? In a case like this, 15 over 70, it's an okay fraction to work with. You could simplify that to, let's see, 3 over 14. So if you call it 3 over 14, that's a fine fraction. Because otherwise, 3 over 14 written as a decimal is 0.214287. Right? It's probably easier just to call this 3 over 14, rather than actually simplifying that. Or, sorry, rather than making it a decimal. Okay, so if that's the case, and y equals 3 over 14 x plus b, or equals about 0.28 times x plus b. And I have these 2 points, and I see that my b is going to be about 14. It's about 14. You're probably okay to just say 14, but how can I be even a little bit more precise here with the points I have? What can I do to find b? Hint, hint. Chris Hubin? Yeah. By hint, hint, I mean I gave you the answer. 25 equals 14 times 50. And this algebra is getting pretty hard here, right? This is getting a little bit of a stretch here. I kept that. It's okay. I'm getting scared. Well, but you have this magical device called a calculator. So you take this and you go times 50. You find, oh, that's a number. So you say, okay, 25 equals 10.7 plus b. We find that 3. So now we have all this stuff. We have that y equals 0.28 times x plus. And all along there, I had been using my fraction. But now that I'm writing this as a number, I feel like it's probably a little simpler to call these both decimals, right? It's not that there's kind of probably a bit of a debate, or you'll hear some teachers saying, "I want you to use fractions because they're more precise," and you're thinking, "Well, I like decimals because they're easier to deal with." they kind of have different good things about them, right? Fractions are more precise. You can be more precise with a fraction. Our exact value is usually written as a fraction or as a radical. But decimals are way easier to conceptualize, right? Like the number 2 over, or whatever it was, 3 over 14. It's like, well, I don't really know what that is, right? It's like kind of a little bit harder to understand. But when I see 0.3, it's like, oh yeah, I remember. I know what that number is about, right? It's kind of like I get the idea of it. Or especially when you deal with like mixed numbers, the number say 35 over 8. It's like, oh man, that's like almost meaningless. It's just like a thing. But then when I simplify that, and I realize that that's like 4.4, whatever. Oh, 4 numbers. 35 over 8, I don't know. 4.4, oh, I get what that is. Right, so that's why in a case like this, like, oh, that's my thing. My line is saying intercept of 14 point something, and a slope of something under 0.3. It goes up by like just under 0.3 per step. All right. And sorry, this is a lesson today where voice is going to keep on blabbing and blabbing and blabbing. So, buckle up. You ready? So now this one. Maya has conducted this survey to determine how salary was related to age. She has this graph. Great, nice graph. Good job, Maya. So now we're interpreting it. And I bet we're actually pretty comfortable with this. What salary would I expect for a 65-year-old person? Well, with this, I'm looking, okay, someone who's 65, that's right between 60 and 70. So I go up. Looks to me like this point here. Yep, is right between 65 and 70. And we find that 65 is at 80,000. So what salary would we expect? Approximately 80,000. By the way, do you think that it's likely that this survey holds true that on average, as people get older, their salary goes up?
Yeah.
Yeah, no. Why yes? Why no? Why do you think that might happen?
The elderly, like, they're old, so they want, like, goatees on them, so they give it better.
Does that seem likely that their employer just wants to go easy on them and use their money? Sounds unlikely to me. Yes, over?
Yes, it goes up to be more experienced, some people, like, as they get older, they have less, like, they forget it. And some people, when they're younger, have more experience.
I would guess that there's a reason. I would guess there's a reason that the data here stops at 65, right?
Yeah, you don't want to have anyone over that.
Well, just retirement age, right? You can start taking old age security at 65. That's the most common retirement age is around 65. But I would think there is a spot where that kind of peaks. You probably, in general, most people's peak earning years are in their 50s, 60s. That is true. But I would think it's, if you were just talking about individuals, this correlation maybe wouldn't hold quite as well. But at a society level, I bet it does. And it's mainly because, like Silver pointed out, his experience. Also, I wonder how someone in their 50s would think about Malak's suggestion that their companies are sorry for them, so they pay them more.
Just like they're old and they can't.
I'll tell my dad that he thinks that. My dad, who is, in his early 60s, yes, he's old. I'm sure he'll love to hear that. Of course, I guess to you guys, I'm ancient, aren't I?
How old are you?
I'm extremely old.
Every teacher says they're extremely old.
I'm not extremely old. I'm very young and hip and with it.
I don't think I'm like
Well,
average. I was
Young people with it, okay.
Someone yesterday was asking about age, and they asked about 1996, that I was doing something in that. They said I was in college in 1996. I was a little bit of it. I was in kindergarten in 1996. So that might tell you my age. I was in kindergarten in 1996.
What is the vocal talk? It's only She's lying.
No, that's true. I went to kindergarten in 1996.
So you're only like 91.
What?
So you're only like, no, my sister was born in
I didn't say I was born in 1996. I said I went to kindergarten.
Well, yeah, if you went to kindergarten, it would have been like 4. I don't know.
Hey, sweet. What year were you 17?
5.
That means you got like 3
Your mom really wanted to get you on the house.
Yeah, this guy's not over in years. Yeah.
Not quite peak earning years. That's what you learned exactly.
Yeah.
He's This guy is a little higher on the spectrum than you guys are at in teaching years, but a little lower than I hopefully will be. Although my job is actually interesting. You guys have probably looked at the Alberta Teachers Compensation Guide. Ours is actually just based on years of experience, up to 10 years of experience, plus years of education. I'm maxed out in terms of years of education. I'm almost maxed out in terms of years of experience. So theoretically, my earning won't go up much if I stay teaching, beyond next year. And I will stay teaching, and hopefully our salaries go up, but I won't actually go up on the grid.
You should start a strike ride.
I have a great job. I like it. Okay, so sorry, that got off the rails slightly. Now for us to go slightly more for this. No, I'm kidding. Okay, so according to your scrap, how old would someone be approximately who makes 70,000? This is actually a pretty bad question, isn't it? How old would someone be? Well, this is an average rate. How old would the average person who makes 70,000? That might be better, because of course there'd be a very significant variance in this. So according to this, 70,000 we're looking, okay, go across. Now notice there are 2 data points right around there, but we're wondering, what does the trend line say?
Like 55.
Yeah, it's right in between there, so somewhere in here.
No, it's beside the line on 60, so it has to be 68.
No, what I'm pointing out is, use the trend
Wait,
line,
no?
use the trend line, don't use the points.
55.
Okay, use the trend line, don't use the points. So I'm going to say 55-ish.
Can we say that on the test?
Well, actually, in a case like this, that is fine, right? Because can I expect you to make an exact prediction based on something that's using a trend line? No. This is saying, according to the trends, some people are on the shelf right now, and I wouldn't like that.
Wait,
In real life, it's probably not happening.
you were 100 on the scrap?
That's the issue, right? That's the issue. Of course, here you have it based on the trend line. You have infinite growth pattern in which, when you're like 162 years old, you're making a lot of money.
Yeah.
Obviously, this is one where the domain and range have to be kept, right? This is a graph that makes sense from about the ages of 15 or 20 up to about the age of 65. Beyond that makes sense.
What company is this? Raise to anything? Whatever.
Maya conducted a salary, starting a survey based on people's salary. That's all we know. That's all we know. Maya just making a survey. Maybe it's just people.
Yeah, I don't like her already. I am.
All right, your turn. Let's see what power you can use Scatterplots for. Good. Go crazy. Only a little crazy.
It's a bit